Hi students, you know well that is life originated and various views have been proposed to explain the origin of life. But the most accepted theory, the view of what is called origin of the life, the chemical evolution. That's the most accepted theory of origin of life. And that was proved by an experiment conducted by two people, Harold Urey and Stanley Miller. So these two people paved the way for understanding the synthesis of organic compounds from simpler inorganic molecules which led to the appearance of life in this world. So this is an experimental setup conducted by them to explain the chemical origin of life or chemical evolution. Now in the past atmosphere, it was just not fully developed, having a mixture of gases, what we have methane, ammonia, hydrogen, along with water vapor. Now he set up an experimental setup in which now the various gases like methane, ammonia, hydrogen and water were allowed to circulate through what is called a large chamber, or allowed to circulate through just what is called a large chamber where we have the electric discharge that provided energy for the union of these different chemicals to form the organic molecules. And this was a thing happened in the past in the primitive atmosphere. Now methane, ammonia, hydrogen and water vapor all combined together, that results in the formation of organic chemicals. Now they set up an experimental setup and provided the same conditions that were prevalent in the past atmosphere. Now the experimental setup contained a large what is called a bulb, and which was connected with electrodes from tungsten electrodes. So when the mixture of gases was allowed to pass through this electrical discharge, they combined together to form organic chemicals. Now we need, actually in the past atmosphere we had methane, ammonia, hydrogen. Now they set up the temperature of 800 degrees Celsius, because in the past atmosphere you know that when the temperature was very high. That was the main source for the union of various chemicals. That's why the sea was considered as a hot and dilute soup. Now he set up an experiment and provided the temperature of 800 degrees Celsius and allowed the gases like what is called a mixture of gases containing methane, ammonia and hydrogen. We also need water vapor. For that, a small flask containing water was kept boiling. So it normally emanated what is called the water stream. So now the water stream, ammonia, that is methane, ammonia and hydrogen mixed together and pass over the electrodes, the tungsten electrodes. While the current is on, now the electrodes produce what is called the electrical discharge in the form of spark. That provided the energy for the union of all these four gases combined together, and at the same time the water condensed to form, the water vapor condensed to form a solution which contained a number of organic molecules. Now the experiment was conducted for nearly about 1 week, and then the liquid collected in the U-tube was analyzed. Now here this is the electric spark provided by the electrodes of tungsten. When the electrodes now spark, they release energy. That energy was used for the union of these four gases. Now we have, that is the combination of actually the gases which are allowed to pass through a condenser, and where the hot water is removed out and the cold water is entering in for cooling what is called the solution. For just actually you see that when the water solution get condensed and cooled and collected in the U-tube. As I mentioned earlier, here the liquid was collected, the experiment was conducted in about a week, and then the solution is analyzed. The solution showed different organic compounds in the form of simple amino acids, glycine, alanine, beta-alanine, then aspartic acid, and the first nitrogenous base that was normally obtained by this method, that is because of what is called the condensation process, because of various reactions in the past atmosphere, was adenine. This was the first nitrogenous base that was made. So we have the glycine, alanine, beta-alanine, aspartic acid, etc. When the experiment was conducted by different people, they were also able to obtain different nitrogen containing compound. The first nitrogen containing compound that was actually made by this method was adenine. So from this experiment, through this Miller experiment, so it had actually given an insight to the possibility of abiogenetic synthesis of what is called the organic compounds in nature from a sample of gases, in which the main source of carbon was methane. The only source of carbon was methane. Other components were received through the different components, the gases, but the main source of carbon for the organic compounds came from only methane. So this is the experiment. The same experiment was conducted by different people. They were able to obtain, I mentioned already, the nitrogenous compounds also. Here these two people extracted glycine, alanine, beta-alanine and aspartic acid in their experiment. Later experiments conducted by different people, they were able to obtain adenine, the first nitrogenous base. This is one entrance question. The first nitrogenous base that was extracted through the organic, that is what is called actually the experimental analysis, adenine. Now, as normally this experimental setup provided energy in the form of electric spark provided by the tungsten electrodes. This setup is also called as spark discharge experiment. The apparatus is called spark discharge apparatus. So it is in support of, that is what is called chemical evolution, the most accepted theory of what is called origin of life, and had been proved by these two people, Harold Urey and Stanley Miller. The full name of these two people, Harold Urey and Stanley Miller. Harold Urey and Stanley Miller, these were the two people conduct the experiments to prove that is what is called the chemical evolution, formation of organic compounds from inorganic chemicals, that is called abiogenesis. I mentioned already, as a new concept, the origin of life is by means of abiogenesis and the diversity of life is by means of biogenesis. The first cell, the pre-cell from where we have diversity occurs, that is called diversity, biodiversity, formation of different groups of organisms. Bear it in mind. Okay, let us go to the next part. What are the various evidences in support of organic evolution? There are different sources in support of organic evolution. That is what we can say, evidences in support of organic evolution. And the first one, evidences from paleontology. Now paleontology means the study of prehistoric life through fossils. Simply we can say the study of fossils. The study of prehistoric life through fossils, and that is called paleontology. Now, a father of paleontology, we have Leonardo da Vinci. He has observed a number of fossils. And the founder of modern paleontology, we have Georges Cuvier. Now, what is the importance of fossils? The fossils are actually the true witnesses of evolution. True witnesses of evolution, or direct documents of evolution. Direct documents of evolution. True witnesses of evolution and direct documents of, that is, various geological strata of evolution. Real documents. Okay, that acting is a key to unlock the mysteries of the past. So it is the only direct evidence when compared to other evidences, though we have evidences from anatomy, evidences from what we have morphology, embryology and others. The only direct evidence for organic evolution came from, that is, the fossils. That's why they are called the direct documents of the various geological state of evolution. So we have the formation of fossils. That process is called fossilization. The process of formation of fossils is called fossilization. It is also called by name sedimentation. It's also called by name sedimentation. Now more fossils recovered from the marine water. The best place of fossilization is sedimentary rocks in marine water. Because the marine water contains a salt, the salinity is the one which preserves the fossils. So, the main place of fossilization is sedimentary rocks, the two in marine water. Now we have different types of fossils. What is fossilization? First I have to define. Fossilization is a process of what we have, the sedimentation or the process of the preservation of dead animals and plants, what we can say the remains of dead plants and animals, through a process of sedimentation, the process of fossilization. What is fossilization? It's a process of preservation of dead remains of animals and plants through sedimentation. Sedimentation means settling of sediments covering the fossils into many layers. That is called sedimentation. Sometimes the sedimentation is also called mineralization, because in most cases the minerals in the sediments are taking part in the formation of fossils. Hence that is what is called mineralization. That is about what is called fossilization, the process of formation or the process of preservation of remains of animals and plants through sedimentation. Now what are the types of fossils? There are three different types of fossils. 1. Actual remains. 2. That is petrification. The third one, molds and casts. Number 1, actual remains. Types of fossils, actual remains. Number 2, petrified fossils. Petrified fossils. Number 3, molds and casts. Molds and casts. These are all three different types of fossils, either actual remains or petrified fossils and molds and casts. We'll see one by one about these three different types. I mentioned the three different types of fossils. Number 1, actual remains. Once the animals or the plants die, the original hard body parts are preserved as such. Preserved as such. In the earth's what is called atmosphere. So the preservation of original hard body parts such as shells, bones or teeth are preserved as such in Earth's atmosphere. This is called actual remains. The original parts are preserved as such. Now this is the most common method of fossilization. The most common method of fossilization. This is very important, most common method of fertilization. When the animals in marine water die, we are talking about the marine water because the marine water is a place of origin of life. Again, more fossils are formed in the marine water body. The sedimentary rocks of marine water. So the best place of fossilization, the marine water. So when the animals in marine water die, their hard parts are covered by sediments, which prevent further decay, further deterioration, what is called the decay or deterioration of that part. This is with reference to the marine water. For example, the hard parts of marine animals were preserved as such due to its salinity. So, see, the vast ocean, now the hard parts of the marine animals are preserved as such get actually preserved as such in the marine water because they are get preserved as such due to the salinity of marine water. What is the reason why more animals get actually preserved in marine water? It's salinity. That is nothing but the amount of salt present in 1 kilogram of water is called salinity. So the salt is acting as a preservative. So that even though animal died, their hard parts are preserved. As such, this is because of the salinity of the marine water. Now, the sedimentary rocks covering you see that one, the fossils, became hardened into stone-like structures. And this is what is called actually fossilization marine water. So more and more layers of sedimentary rocks were added over what is called the hard parts, either the teeth or the shell, so that we got what we have definite layers or strata of sedimentary rocks. Now we have some examples for this one also. Example number 1. Number 1 example for actual remains. The only mammoth which was recovered from, that is the frozen coast of Siberia. The one which lived 22,000 years ago. So the entire elephant, so woolly mammoth means the ancient elephant, the ancestors of the present elephant, having hairs all over the body. So they were recovered from the frozen host of Siberia, which lived, that is 22,000 years ago. So actual remains, entire animal was preserved. The second one, several humans and animals preserved intact in the ancient city of Pambi. Now this is a city in Rome, that is in Italy. So the Pambi city in Italy, that is in Rome. Now there was a volcanic eruption from the Mount Vesuvius just in 79 AD. This happens in 79 AD. So the Mount Vesuvius actually gushed out what is called the ash, which covered several animals, several human beings in a vast area. Till today, they have not yet recovered the bodies of animals and humans which were buried by this ash. So they are just actually unearthing, that is what is called the ash, and getting the human beings and animals, still the process is going on. So they have seen actually number of human beings preserved as such. So these are the 2 examples for actual remains. Now we have to go for the second type, what is called petrification. The second type of fossilization, petrification. What is petrification? When the animal or plants die, the original body parts are replaced molecule per molecule by some minerals. During this course, what will happen? The original substance being lost by means of disintegration. This is called petrification. And the fossils obtained by this process are called petrified fossils. Petrified fossils. So the second method, petrification, the original body parts are replaced molecule per molecule by the minerals, some certain minerals. And during that process, in course, what happened? The original substance of the body being lost. Now what are the minerals normally used in this process? We have iron pyrite, different types of actually minerals are used. 1. Calcium carbonate. 1. Calcium carbonate. 2. Iron pyrite, the ore for iron. Then silica or bicarbonates of calcium and magnesium. This is called double carbonates. So you can say double carbonates of calcium and magnesium because we are using double carbonates. These are the different types of minerals used for petrification. Now, if calcium carbonate is used, then it's called calcification. If iron pyrite is used, then it's called pyritization. This is what's called carbonization or carbonization or calcification. Iron pyrite, pyritization. And when you're using what is called silica, this is called silicification. Silicification. When double components of calcium and magnesium are used, then it is called dolomitization. Dolomitization. So these are the different methods of petrification based on the nature of the minerals involved in replacing the original body parts. We have carbonization, pyritization, silicification and dolomitization. So that is about what is called petrification. When the animals or plants die, before they undergo disintegration, they might leave some indelible impressions. Indelible impressions on the soft mud. So indelible impressions on the soft mud. Just imagine that when an elephant walked on a soft mud, it left indelible impressions in the form of foot. Such indelible impressions that are formed on the soft mud, they are called as moles. The indelible impressions. Either the elephant walked or a tiger walked, they left what is called the shape of a palm or the foot. That is called indelible impressions or cavities. For example, for making a brick, we need a mold, a frame, a rectangular frame. That is called as a mold. Or in the case of Vinayak Chaturthi, we are making what is called the statue with the help of a mold. Sometimes what will happen, these molds get filled up by some minerals, then hardened into fossils. And such actually the materials which fill up, that is what is called the molds, and having the shape of the what is called the mold, because of mineralization, they are called as a cast. So in the case of making a brick, the wooden frame is the mold and the brick is the cast. Same manner, the indelible impressions may get filled with what is called actually the hard minerals. Then they become hardened into fossils. Such fossils are called the casts. So molds and casts are another type of fossils. Even in the case of actual remains, you know that once some insects are preserved as such by means of the exudate from the plant body in the form of resins. For example, amber. Amber is a resinous product and exudate from the plant body. It is acting as a preservative when some insects stuck to this amber. Now the insect was preserved as such for a long duration. That's an example for actual remains. One of the examples, though not given in the book, this is also another one. So the indelible impressions, that is form the molds, and they are filled with what is called the cast. Now another one, what do you mean by coprolite? What do you mean by coprolite? So this is what is called hardened fecal matter. Hardened fecal matter or fossilized fecal matter. Fossilized fecal matter or preserved excrement. Preserved excrement. We hear the word what's called coprophagy. The word coprophagy refers to animals which feed on their own what is called the feces. Now coprolite is a kind of fossil, that is otherwise called hardened fecal matter or fossilized fecal matter or preserved excrement in the form of pellets, small pellets. When these pellets were analyzed, one can able to or which enables to understand the nature of the diet of the prehistoric animals in which they thrive on. So by analyzing what is the importance of coprolite, because because it is a fecal matter hardened into stones and then it is forming what is called the fossil. Entire fecal matter hardened into stone by replacing, that is what is called the original substance, by mixed minerals. So if you are analyzing the coprolite, one can understand the nature of diet in the prehistoric humans or animals. We can see prehistoric animals which thrive on what type of food materials they took. So by analysis of this coprolite, one can understand the nature of the diet of the prehistoric animals. So these are all evidences coming under the paleontology. Okay, we have to move to the next one, evidences from comparative anatomy and morphology.